Hello, my name is Chan. I'm the group leader of Group 1 and today I'm here to present our group lab project for operating systems. My group consists of 4 members, namely me, Chan, and then you, Darian, and Alex. Here is the task distribution. We split the tasks equally so everybody had equal participation in the project. Before we move on, let's give a brief overview of the project that we're doing. So the lab project wants us to build a program that simulates multiple reader and writer threads accessing a shared file with the following rules. Multiple readers can read the file at the same time, but writers must have exclusive access, meaning no readers or other writers can access the file while a writer is writing. Now, this lab project is to ensure consistency of the shared data while allowing concurrency where safe inside the program. So without further ado, we'll now move on to the coding implementation. So to simulate a Unix environment, we chose Ubuntu that is run inside VirtualBox, and our chosen language for this project is C. Therefore, I can show you here where I nano my project file, which is called project.c. You can see the source code here. Now, I will explain the source code later in the video. As of now, I'm just here to show that the code runs. So when I do this, can see that, the threads, the reader and writer threads are accessing the file concurrently. In fact, I can show you it if I open another terminal and then I access my simple.txt file, which is the shared file in this project. And as you can see, the writer threads have written into the file. So for easier recording, I'm going to move to VS Code in order to explain my code. And so let's begin. So here are the libraries used: stdio, std library, pthreads, uni, std, time, and string. So we declare our global variables, which is the file. This points to our file, which is simple.txt, the shared file. And then we declare the number of reader and writer threads. In this case, we set each of them to 5. Then we have 2 mutexes. One is called the read mutex, which locks or unlocks the reader threads, as well as the write mutex, which locks or unlocks the writer threads. Read count tracks how many readers are currently reading. If it is 0, that means no readers are reading, and if it's more than 1, we have to lock the write mutex. So since the write operations can't occur at the same time as a read operation. So we'll go to the writer first, since this is the important part. Each writer will have a unique ID assigned to them. In this case, it is an integer ranging from 1 to 5. Iteration essentially tracks how many lines the current thread has written. And then we go into the while loop, which we put 1 here in order to make it run forever. So we have this function which logs that which writer thread is trying to write into the console. And then once it tries to write, we have to lock the mutex. So we have this pthread mutex lock here, so that other writers and other readers won't be accessing the shared file when the writer thread is writing. And once the writer thread has access to the file, we say here, writer starts writing. So basically this logs when the writer starts writing. And then we specify the file here. It's a simple.txt file. And then we append it, meaning we add more lines at the end. So if the file is found, it will get the timestamp. We'll get into the function later. But this essentially prints out the time. And then it writes into the file writer, let's say 1. Writer 1 will be writing the iteration of 1, which means writer 1 has written its first line into the file. And then it will sleep for a random duration between 1 and 10 seconds here. This is to simulate the write operation maybe taking longer. And then once it's done, it will close the file. Once it closes the file, it will unlock the mutex so that other threads can access it. And then it will wait a random duration between 1 and 20 seconds before writing the second line into the file. Now we move on to the reader function. As always, there is a unique ID assigned to it. Same case here is a unique integer from 1 to 5. And as also, it is inside an infinite loop, as we want it to run forever. So when it reads, it has to log the mutex, the read mutex, and then increase the read count. That way we can keep track of how many threads are currently reading the simple.txt file. And if it's the first reader to read the file, it will have to log the write mutex, as we do not want the writing operation to occur at the same time as the read operation. So once that's done, we instantly unlock the read mutex, as we want to allow other read operations, as there's no restriction on that. Multiple readers can read the same file at the same time, but you cannot have a write and read operation at the same time. So here we specify which reader is reading, and then as always we specify the file path, and then we had to print what it was able to read. Basically, this line and this line prints out the file contents, so as to see if it's working properly. Then once it's done, it closes the file, logs that it has finished reading in the console, and then logs the read mutex, and then reduces the read counter. So if it's the last read thread to read the file over here, then we will allow the write mutex, allowing write operations. We'll get into detail about this later in the results section, but as always, we specify a duration for it to sleep, as in wait before another read operation is performed. Moving on to the main function, so we have here, we print that the process has started, or the program has started. Then we call the clear file function, which I'll get into later, to clear the contents of simple.txt. Then we initiate two mutexes, which is the read mutex and the write mutex to null. Then we declare two arrays, one being readers and one being writers, which are pthreads arrays to contain each of the reader and writer threads, as well as the reader and writer IDs. They are both arrays which store information basically about the threads. Then we use those to create reader threads using a for loop. So basically we declare reader ID 0 in the first position of the array. It will contain reader 1, and these are basically the command for it, as well as the writers. And then we use pthread join, basically run the function inside of the thread, and that's about it. These two here will never be executed, since our program has no endpoint, as it runs infinitely. And that's about it for our code. So now I'll go through the tools functions, which are optional here, which is get timestamp, which gets the current timestamp. We just use the time from the time.h library, and we get the local time. Log action basically just combines the timestamp with the message the reader 1 has written, or that message, as well as the clear file function, which opens the file, closes it, and then clears it, basically. So that's it. We will now move on to the results section of our project. So in our report, we have this snippet of the running process log, which we analyze to discuss about what we found out. So it's stored in the table here. So the first operation, basically reader 4 starts reading. The read count increases by 1, and then the status is the write mutex is locked. We don't lock the read mutex, as it locks and unlocks instantly. because we want to allow multiple read operations to occur at the same time. And then it was written that writer 3 was trying to write, but since the read count is 1 and the write mutex is still locked, it cannot write, so it has to wait. Then reader 5 starts reading, which increases the read count again. Again, the write mutex is still locked. Then reader 2 starts reading, reader 3 starts reading, making the read count at a total of 4. So writer 1 cannot write as well, as the read count is not 0. Then reader 5 finishes reading, therefore we decrease the read count by 1, making it 3. Again, writer 2 tries to write, but he has to wait. Reader 4 finishes reading, so reduce again. Writer 5 tries to write, but it can't because read count is still not 0. Same here with writer 4. Then reader 1 starts reading, then reader 2 finishes reading, making it back to 2. Then reader 1 finishes reading, making it now 1. And now, finally, reader 3 finishes reading. And so now, there aren't any reader threads running currently. Therefore, it unlocks the write mutex, allowing for writer 3 to start writing, which was the first one to start writing. As you can see here, that was the first one. So it's a first in, first out operation. Then, once writer 3 starts writing, it will lock the write mutex as well as the read mutex, since we don't want any other read or write operations to occur at the same time as one read or one write operation. Then when writer 3 starts writing, we will lock the write mutex as well as the read mutex, as we don't want other operations to interfere with our writing process. Then it finishes writing, then the next writer in line will start writing, and so on and so forth. So it can be seen here that our implementation is correct, as we allow for concurrent access. Multiple readers are allowed to read the file at the same time, but when writing, no other operations are allowed. And that's about it. Thank you.